Internal energy of the system also increases. Anomalous expansion of water are critical greater than specific heat at constant volume. Volume of water decreases and density increases. Hello students, this is SD Sir from the Temple of Excellence, Vidhyaashram Pre-University, Mysuru. Before I continue the session on thermal properties of matter, let us recall the concepts which happened in the previous session, where we learned a very beautiful topic called specific heat of materials. Specific heat. Heat, a form of energy, but why do I call it as specific heat? We told it was the amount of heat required to raise the temperature of 1 kg of a substance by 1 Kelvin. Therefore, if you can see the specification there, I am supplying heat to a substance whose mass is 1 kg so that its temperature increases by 1 Kelvin. Since we specify mass to be 1 kg, increase in temperature to be 1 Kelvin, therefore the amount of heat supplied is called specific heat. We then studied about specific heat at constant volume and specific heat at constant pressure. Same definition. For constant volume, heat is supplied by keeping volume constant. For constant pressure, heat is supplied by keeping pressure constant. We finally studied molar specific heat, and we told the device which measures the amount of heat supplied to a body or removed from a body is called calorimeter. Now, continuing my discussion, what is that I have in store today? We study the consequences of specific heat. Now, dear students, at the onslaught, we will be answering a very classical question, and the question is CP greater than CV justify? I have to physically analyze, is CP greater than CV or CV greater than CP, and I should also give a proper justification to whatever I analyze. Fine. I've made the conclusion here. The conclusion is, by theoretical analysis, CP is always greater than CV. Scientific reasoning says specific heat at constant pressure is always greater than specific heat at constant volume. Please do know this. CP is always greater than CV. My dear students, you need to know the reasoning. My entire thermodynamics lies in understanding the fact that CP is greater than CV. Why? This is how I reason out. Now, when heat is supplied at constant volume, what happens? Here is a diagram. I am supplying heat to the system, a cylinder, by keeping volume constant. These are the molecules of the gas. And when I say volume has to remain constant, I mean I will not allow the molecules to expand. I will not allow the molecules to occupy more space. I constrain the space. I constrain the volume. How? I have already told in my previous session. Insert something called as a piston. It is nothing but an iron rod. Just fix the rod into the cylinder. Insert the piston into the cylinder. The space occupied by the molecules get confined. I am restricting the volume of the molecules here. So volume is made constant and heat is supplied to the system. Now, under this situation, how is the heat utilized by the molecules? Whatever heat you are supplying to the system, keeping the volume constant, how is it made use by the molecules? When I supply heat, I am increasing the kinetic energy of the molecules, which means in this case, I am increasing the internal energy of the system. Little now, I don't talk too much about internal energy. When I take up the chapter kinetic theory, I make it very clear. But just now understand, as heat is supplied under constant volume, keeping the volume constant, the kinetic
energy of the molecules, the kinetic energy of the system increases, which means I am increasing the internal energy. But is expansion happening? No. There is no increase in volume, no expansion of the gas. Therefore, we say here, when heat is supplied at constant volume, it is used to increase the internal energy of the system. So, only one activity is being performed when heat is supplied at constant volume. And what is that? It is to increase the internal energy of the system. But now let us understand what happens when heat is supplied at constant pressure. Now, I need not restrict the volume. I don't refrain the space occupied by the molecules, but I am supplying heat at constant pressure. Pressure, force per unit area being same. How do I make pressure constant? Supply heat by keeping temperature constant. Don't change the temperature of the system. Supply heat at constant temperature. Pressure on the molecules becomes constant. Now, in this case, again, I am supplying heat. I might have kept the pressure constant, but still I am supplying heat to the system. Naturally, kinetic energy has to increase, which means again there will be increase in internal energy. No issue. Again, keep the pressure constant. Yes, internal energy of the system also increases. Now, as I told, the molecules have all freedom in this world to occupy more space. Only pressure is kept constant. They occupy more volume. Expansion of the gas is seen. Therefore, under constant pressure, the gas expands. So, my dear students, if you observe here, there are two activities happening under constant pressure. One, the internal energy of the system increases. Second, expansion of the gas. So very evidently, Cp has to be greater than Cv. So again I say, heat supplied at constant pressure is always greater than heat supplied at constant volume. Why? When volume is kept constant, only one action is performed, that is increase in the internal energy. When pressure is kept constant, two activities happen. Two actions take place. One, yes, there is increase in internal energy. Simultaneously, there is expansion of the gas. And therefore, we say Cp is greater than Cv. Now, one another beautiful consequence of specific heat, which is much related to water, something called anomalous property of water. We also call this as anomalous expansion of water, a critical property of water which is responsible for the life of aquatic animals during severe winter. And probably if I see CET papers, entrance papers for the past 5 years, there is one question always asked from this concept: anomalous property of matter. If we glimpse back to whatever we have studied, I have told you that the moment heat is supplied to matter, there is expansion seen in it. Whenever you supply heat to a substance, immediately there is expansion. Thermal expansion ಓದಿದ್ವಿ. Increase in the dimensions, maybe length, maybe area, maybe volume. But the conclusion was, the moment heat is supplied, there is increase in the dimensions, or the material expands. But very amazingly, this doesn't happen with water. So we say, when heated from 4 degrees Celsius or 0 degrees Celsius until 4 degrees Celsius, water does not expand, but the other way, it contracts, decrease in volume. See, very beautiful. I expected that the moment heat is supplied to water, it has to expand. But shockingly, from 0 degrees Celsius to 4 degrees Celsius, water does not expand. When you heat water from 0 degrees Celsius to 4 degrees Celsius, there is no expansion seen. But the other way, water contracts. ವಾಲ್ಯೂಮ್ ಜಾಸ್ತಿ ಆಗಬೇಕು ಅಂತ ಎಕ್ಸ್ಪೆಕ್ಟ್ ಮಾಡಿದ್ವಿ. ಆದರೆ 0 to 4 ಡಿಗ್ರಿ ಸೆಲ್ಸಿಯಸ್ ಈ ಟೆಂಪರೇಚರ್ ಮಧ್ಯ ವಾಟರ್ ಕಾಂಟ್ರಾಕ್ಟ್ ಆಗಿಬಿಡುತ್ತೆ. ವಾಲ್ಯೂಮ್ ಆಫ್ ವಾಟರ್ ಡಿಕ್ರೀಸಸ್. Expansion of water happens only above 4 degrees Celsius. So when you heat water only above 4 degrees Celsius, it expands, and this is called anomalous expansion of water. So what is anomalous expansion? The unique property of water to expand only after a temperature of 4 degrees Celsius. That is what is called anomalous property. So what is happening in between temperatures 0 and 4 degrees Celsius? There is no expansion seen, but the other way, water contracts. So, if you observe the graph, which I call change in phases, x-axis, I have marked temperature, y-axis, volume. You see, when the temperature is 0 degrees Celsius, water has maximum value, and as temperature starts increasing, temperature goes on increasing, surprisingly, volume of water is decreasing. Where? Up to a temperature of 4 degrees Celsius. And once after 4 degrees Celsius, again there is increase in volume, and this is called anomalous transition. After 4 degrees Celsius, sudden increase in volume, water expands, and that is what we call anomalous expansion of water. So if I understand the density curve here, at 4 degrees Celsius, volume is minimum, which means density is maximum. After 4 degrees Celsius, volume goes on increasing, density goes on decreasing. So this is what we call anomalous expansion of water. Now, this is what I frame to explain how anomalous behavior of water supports aquatic life. See, during winter, very intense winter, a chill day, water cools below 4 degrees Celsius. Very, very chill day, a cold day, water is cooling below 4 degrees Celsius. So what should happen? Below 4 degrees Celsius, there should be contraction of water. That is, volume of water decreases and density increases. Below 4 degrees Celsius, no expansion. So volume decreases, density increases. Cooler water moves to the surface and denser water sinks. Water which is cold, which moves to the surface, and water with more density, it sinks. Therefore, surface water freezes at 0 degrees Celsius. Water below does not freeze, and hence aquatic animals survive during winter. So, my dear students, today we studied a classical reason as to why Cp is greater than Cv. Whenever you supply heat at constant volume, only increase in internal energy. At constant pressure, energy increases as well as the gas expands. So Cp greater than Cv. What about anomalous expansion? 0 to 4 degrees Celsius. No expansion seen. Volume decreases, water contracts, and expansion is seen only above 4 degrees Celsius. Why this property is significant? It helps the aquatic animals to survive during intense winters. Hope you have understood this session. In my next session, I turn out with the different modes of heat transfer. Until then, thank you.